Good day to each and everyone. So this is the first official lecture video in the subject Foundation Engineering, and I am Engineer Alex M. Balubal, your professor in this subject. So the learning objectives of this lecture video is to define what foundation engineering is, to differentiate between shallow and deep foundation, and to enumerate different types of shallow and deep foundations. First, let us define what foundation engineering is. So, foundation engineering is concerned with the evaluation of the ability of the earth to support a load. And with this, you now understand why soil mechanics is a prerequisite of this subject. Also, foundation engineering involves designing a substructure or transition member to transmit the load of the superstructure to the earth. So we mentioned here substructure and superstructure. So some of you may wonder what's the difference between the two. So a very simple difference between superstructure and substructure is that a substructure is that part of a structure found in contact with the earth or anything under the earth, like this portion here, or a building. While the superstructure is what you find above the earth. Now, if for a bridge, the substructure are these parts. So it may involve the piles, the footing, and anything found at this portion. While the superstructure part includes the columns or the pier, the deck slab of the bridge, the cables, and so on and so forth. Now let's talk about the difference between shallow foundation and deep foundation. As to the dimension of the foundation, it is an agreement that if your depth is less than the width, then it is considered as shallow foundation. Whereas if your depth is much greater than your width, then it is deep foundation. Now, in some books, they define that shallow foundations has a depth of less than 3 meters, while deep foundations has a depth of greater than 3 meters. Now, as to the load carrying capacity of the two, we expect that for deep foundation, it can be able to carry heavy or huge loads. And of course, we expect that for shallow foundations, it is used only for light construction. Now, as to the load transfer, from the superstructure to the earth, then for shallow foundation, it only rely on end bearing. For deep foundations, it could be end bearing as well as skin friction. Or both. Now, what could be the advantages and disadvantages between the shallow and deep foundation? Now, for shallow foundation, we expect that the construction method is simpler or easier as compared to deep foundation. This is for the construction method. And for deep foundation, it will be complex. Another one is for the lateral support. For lateral support, since deep foundations are embedded into the earth, then we expect that they will provide good lateral support. And on the other hand, for shallow foundation, it has weak lateral support. Aside from that, another disadvantage of shallow foundation is that soil settlement can be expected. So I think these are among the most common differences between shallow and deep foundations. Now let's enumerate the different types of shallow foundations. The first one on our list is the wall footing. So wall footing, as you all know, is the support. Now the first on the list is wall footing. I know you are familiar with this already, but for illustration purposes, wall footing is usually rectangular in cross section, and usually it has these reinforcements, and it is supporting our usual CHB. So it would look something like that. Now our next type of shallow foundation is the isolated footing. There are different types of isolated footing depending on the shape. So isolated footing can be square, rectangular, or even circular. But the most common isolated footing that you can see in regular construction is something like this. Okay, so I think it is clear in this drawing that this is a regular isolated footing. There are different types of isolated footing depending on the shape. So this is an example of a square isolated footing. Another type of isolated footing is the stepped isolated footing. And it looks something like this. It could be more than 2 steps depending on the depth of the footing. Sometimes it is sloped and it looks something like this. Okay. And lastly, it can be curved or arched. So just change this part into a curved line and it is already considered to be arched or curved. Now arched isolated footing is usually combined with circular shape and it is used commonly in the foundation of windmills. Now let's go to combined footings. There are three different types of combined footings that we will be discussing. The first one is the rectangular combined footing. The other one is trapezoidal. And the last one is strap or cantilever. So I will not discuss the difference between the three anymore. Anyway, we will be discussing that in our future topics. But for the sake of illustrating it, let me try to draw a combined footing. So this is uh, an example of a rectangular combined footing. The trapezoidal one looks something like this. Okay. And finally, the strap or cantilever is just a combination of two isolated footings. But the only difference is that these two isolated footings are combined with a strap beam. So this is what we call the strap beam. So that's why it's called strap or cantilever combined footing. The next type of combined footing is the strip or continuous footing. And if you just imagine our wall footing a while ago, it is similar to that, but in this type of footing, it is supporting rows of columns. So instead of walls, this type of footing is supporting several columns in a row. Okay, so this, or it looks something like that. The next one is the mat or raft foundation. Now, mat or raft foundation supports all the columns in a certain area. So just imagine if your foundation looks like this. So all the columns are being supported by a single foundation. The use of isolated footing would be enough. Now, there are times that if your bearing soil is soft and that the resulting area of your isolated footing would look something like this. Then that is the time to use combined footing. So when your design dimensions for your isolated footings overlap each other, then that is the time to use combined footing. Or in case you have several columns in a row and it is overlapping, then also it is advisable to use strip footing. And if your soil is really soft, that it will result to overlapping in all places, then that is the time to use raft or mat foundation. Now, there are times that your mat or raft foundation would be called buoyant foundation or buoyancy raft. When will that happen? Okay, so if you use mat foundation, assuming that this is the natural grade line, and this is your foundation, and this is your superstructure. Now, if the weight of the excavated soil is equal to the weight of the building, then that is the time that your foundation would be called buoyant raft or buoyant foundation or buoyancy raft. If you recall Archimedes' principle, then that's the reason behind why it is called buoyancy raft. Now let's start discussing deep foundations. The first on the list is piles. Piles can be classified depending on the materials being used. The oldest type of pile is timber piles. The second type of a pile, according to material, is steel. And we have also reinforced concrete and pre-stressed concrete piles. Pre-stressed concrete piles can be also classified as pre-tension or post-tension. Anyway, you will be learning these two technical terms when you enroll your pre-stressed concrete design. By the way, as to method of construction, these types of piles could be further classified as driven piles. Now, the other method is called cast in place or board piles. We'll talk about this later. So let me first remove this and discuss what are some of the advantages and disadvantages of using these different types of piles. Now for timber pile, one advantage of timber pile before is that it is economical and it is readily available. Now the disadvantage as to method of construction is that timber piles tends to broom when being driven. So what does that mean? When you hammer the tip of a timber pile, it brooms, okay, as the fibers shatter. So when you need to add some more length of the pile through splicing, then you need to cut it and then splice. And of course, splicing again is difficult for timber piles. For steel piles, the advantage is that it is easy to drive. Okay? But one disadvantage of using steel pile is it tends to buckle when it hits hard obstacle underneath the earth. That is why reinforced concrete and pre-stressed concrete are the most widely used piles or driven pile. Now, a while ago, I mentioned that all of these four are considered to be driven piles. The other type of pile as to method of construction is the cast in place or board pile. Now in some textbooks, they call this shaft or pier and so on. But here in our country, it is most commonly known as bored pile. Now, as the term implies, this pile is not driven, and instead it is drilled and cast in place. I will be placing a link where you can watch a YouTube video on how a board pile is being constructed. The second major type of deep foundation is caisson foundation. Caisson foundation is being used whenever piles are not feasible, like what happened in Bued Bridge project. Now the bridge is located at the intersection or boundary between Pangasinan and La Union. The Bued River has a soil profile that looks something like this. So upon investigation or geotechnical exploration, it was found out that there are several boulders found underneath the river basin. Now, if you try to use pile, may it be a driven or bored pile, then there's a possibility that the pile will be obstructed by these gigantic boulders. And with that, there's a possibility that the underlying hard strata cannot be reached. Now, with the adoption of a caisson foundation, the problem regarding the presence of big boulders is somewhat solved. For your information, the Bued Bridge project is the first to adopt a caisson foundation in the country. Now, there are three types of caisson foundation. The first one is the open caisson. The second one is the box caisson. And the third one is the pneumatic caisson. Now, the first one is what Bued Bridge project adopted, the open type caisson. Now, to give you a simple difference between the three caissons is that the open caisson is open at the top and the bottom. The box caisson is open at the top but closed bottom, and the pneumatic caisson is closed at the top but open at the bottom. The caisson used in Bued Bridge. Now, if you cut through this section, it looks like this. Now, you could just imagine if the dimension of this caisson is more or less 6 meters by 8 meters, and the height is around 5 meters. So you can just imagine how huge the caisson is. Now, the caisson is first cast in place. So through surveying, they determine the exact location and then excavate at the riverbed where to cast it. Now after casting, the caisson is sink through gravity, through its own weight, by excavating the soil inside the caisson. Slowly, the caisson will go down by itself due to its own weight. So slowly, the caisson will go down. Until it reaches the desired elevation. Note that at this portion is the cutting shoe. So this is made of a metal sheet so that during sinking, this will not break. Imagine if this caisson has no cutting shoe and this is only made up of concrete. The first portion that will break during sinking would be this part. So to avoid that to happen, cutting shoes were placed. So that is placed all around the perimeter of the bottom of the caisson. So when the caisson is sink to its desired elevation or level, the void portion here will be poured with Cyclops concrete. Now what is a Cyclops concrete? So it is a regular concrete, but since there are very big boulders present within the vicinity, and to economize on the volume of concrete to be used inside the caisson, upon pouring, boulders are dropped into it to save on the volume of the concrete. Now this part here, the Cyclops concrete, is actually non-structural. It's just placed there in order to fill the voids. So it will be concreted up to this level. After that, the reinforcing steel bars for the footing will be placed. So this is massive reinforcing steel bars, including the reinforcements of the column, or in bridge terminology, it is called pier. And then they cast that until the superstructure. Now there are problems also being met during sinking of caisson foundation. There are times that the boulders is exactly at this portion. There are two piers that have met this kind of problem in Bued Bridge. Now what happens if there is a big boulder obstructing one portion of the caisson? Now the effect would be the caisson will tilt during sinking. And if this is not anticipated, the level of the caisson will be difficult to put back, or the plumbedness of the caisson is difficult to be reverted. So one solution is to break this big boulder, and depending on the size of the boulder, it will take days or weeks in order just to break this boulder, so that after breaking, the sinking of the caisson will resume. Now let's go to the next type of caisson, which is the box caisson. Now box caisson this time is open only at the top, but closed at the bottom. So let me draw an example of a box caisson. So I think you can imagine this type of caisson. It is a cellular box caisson. Cellular in the sense that it has 4 cells. Now the bottom of this caisson is closed. So the method of construction is this way. First, the caisson is casted at dry area. So assuming this is seaside, this is the sea. The caisson is casted somewhere here at the dry portion. And then, when the caisson is already casted, a boat will pull it, or a tugboat will pull it to transport it to its desired location. Now, when the caisson has reached its desired location, it's still floating. Say, for example, this is the desired location. The caisson now is filled up with water. So when the caisson is filled up with water, definitely it will sink to the bottom of the seabed. And when that happens, the caisson will serve as the foundation of future piers of bridges. Now let's discuss the last type of caisson, which is called the pneumatic caisson. So pneumatic caisson is actually not a foundation in itself, but it is used to construct deep foundations. So let me draw a schematic diagram of pneumatic caisson. Okay, so this is a cross-section of a pneumatic caisson. A pneumatic caisson is open at the bottom and closed at the top. It is closed because it means that the caisson needs to be airtight. Now, why does it need to be airtight? Now imagine this is the sea level and this is the dry workspace where man can work. So water needs to be pumped out in order to have a dry working area for the construction workers. Now since the inside chamber of the caisson is pressurized, the number of hours that workers can do work is limited. So it is not possible that they can consume 8 hours a day of work because after getting out of the caisson, you need to be decompressed before going to normal environment. When workers work inside the caisson, uh, more than the allowable working hours, then there is a chance that they can catch the caisson disease. So to summarize what we have learned in this lecture, we have known the definition of foundation engineering. We were able to differentiate the shallow and deep foundations. We were able to enumerate and understand the different types of shallow foundations, like wall footing, isolated footing, combined footings, strip or continuous footing, and mat or raft foundation. We were also able to enumerate the different types of deep foundation, and mainly they are composed of piles and caisson. And the piles can be classified as driven and bored depending on the method of construction, and the driven piles can be classified further into 4 different types of piles depending on the materials used. And finally, we discussed the 3 different types of caisson: the open, the box, and the pneumatic.